Hi, welcome to my second part of MATLAB tutorial on FIR filter. Alright, before we proceed with today's tutorial, let me give you a brief snap on what we have done on the first tutorial. Alright, in first tutorial, we have conducted the filtering for this noisy signal in time domain by using convolution technique. Alright, how we do that? We take this signal here and we convolve with the impulse response for the low pass filter, and we get the third signal as our result. Okay, we convolve the first signal and second signal. Alright, then as a result we got the third signal. This is the filtering process in time domain. Alright, but today we're going to do almost the same thing, but we're going to filter the noisy signal here in frequency domain. Alright, how are we going to do that? We're going to transform the time domain signal here into frequency domain by using FFT. We're going to transform the impulse response for the low pass filter here into frequency domain, and we're going to multiply both of them. Alright, once we get the result, then we're going to transform from frequency domain into time domain by using inverse fast Fourier transform. Alright, okay. If you want to get more detail about the first tutorial video, you have to watch it. I'm going to give you the link on the description later. Alright, okay, without wasting our time, let me proceed with the second tutorial today. Alright, I'm going to continue from the first tutorial coding. Okay, alright, as I mentioned just now, what we're supposed to do, the first step is, okay, to transform the noisy signal from time domain into frequency domain. Alright, here we have done that. Okay, the next thing is we have to transform the impulse response for the low pass filter from time domain into frequency domain. Okay, how are you going to do that? The same process. Okay, so let me give you a variable fh equal to fft of h with the length of n fft2. Alright, then we're going to take only the left part of the frequency, because FFT going to give you a symmetrical signal, negative and positive frequency, okay, on right hand side and left hand side. So we're only going to take on the left hand side, the positive frequency. So fh equal to, use the same variable fh, but we're only going to take from 1 until n FFT2 divided by 2. We are dividing the x-axis of the frequency into half. Alright, that's what we're doing here. Alright, so as I mentioned just now, in frequency domain we're doing the filtering by multiply the impulse response with the noisy signal here. So create a new variable mul equal to fh, okay, multiply by sample, okay, fy. That's all, as simple as that. Okay, but when we do that, let me try to run and see. Okay, what happened here? For the mul, we have a complex number here. Okay, so what we're supposed to do, we only have to extract the magnitude by using absolute command. So let me try to plot and see what happened there. So plot, alright, absolute of mul, right, and press F5 as a shortcut. There you go. This is the frequency signal that we get after we do the filtering. Alright, for have a better understanding, let me try to plot all three of the signal: the noisy signal, the impulse response, and the result from the filtering. Okay, so we can use, we are going to use the command subplot. Alright, we are going to have 3 rows, 3, 1, 1. Alright, first we're going to plot the here the noisy signal. So absolute of fy divided by maximum of fy. Why am I dividing the fy with the maximum of fy? Because I'm normalize it to 1. Alright, normalizing the amplitude to 1. Alright, then we're going to have the second subplot, 3, 1 column, second row. Okay, it's going to be plot what? Now we are plotting the FH, the impulse response for the low pass filter. The same thing, we're going to take absolute, alright, then we're going to FH divided by maximum, okay, of FH. Right, that's all. And finally, we already have the signal. Okay, going to add the subplot. Subplot, third row, first column, and the third. Alright, there you go. Here we can add the X FFT, which is the X axis for the frequency. Alright, X FFT. Alright, okay, let me try to run and see what happened there. There you go. Okay, now we have, okay, this is our noisy signal in frequency domain. This is the impulse response that we use to filter this signal. Whenever we multiply both signals here, we got the final signal, the low frequency component, as our result. Alright, as you can see from here, alright, we have 1 kilohertz represented by this portion here, 20 kilohertz represented by the second frequency signal here, and finally 30 kilohertz represented by the third signal here. Okay, when we do the multiplication in frequency domain, okay, what happened there? Okay, here the impulse response for the low pass filter, we have a magnitude almost 1 here, where whatever the value represented by the low frequency component, multiply with the magnitude 1, so we retain the signal here. But what happened outside the curve here? Outside the curve, the value here almost all 0. So whatever the magnitude 0 multiply with the high frequency component here, the return is 0. So all the frequency signal here attenuated here. Alright, so that's why we only have the low frequency component here. As simple as that. Okay, how are we going to retrieve in time domain? We're going to do IFFT. Alright, as simple as that. Now let me try to draw the time domain signal with the frequency domain signal together and see how it's going to look like. Alright, to plot the time domain and frequency domain together, what we're supposed to do now? Okay, we're going to use the subplot command, but instead of using 3 1, now we're going to change into 3 2. Alright, so we're going to bring back the convolution process as well. Okay, what we're going to change now? Okay, initially we have used the subplot to plot all the frequency component, and my previous video I have shown you how we're going to do the subplot for the same in time domain. Okay, now we're going to bring both of them side by side. But as you can see here, what happened here, you have to choose the row and also the column properly for the subplot. Otherwise, you're going to mess up. Let me show you what's going to happen here when we choose 3 to 1 until 3 to 6. You're going to see what happened now. Alright, see here, we have the frequency here, the frequency domain of Fy. Then the second here is the frequency domain for the impulse response. But we don't want this. We want the time domain to be here and frequency domain to be here. So we're going to start from the time domain signal first. Alright, let me close this window here. Okay, what we're going to do now, we're going to plot here. Okay, we're going to bring this portion up. Okay, okay, now we're going to present it as our first figure. This is time domain. What going to be our second figure? This is going to be our second figure. Okay, this is in time domain and this is the signal in frequency domain. Alright, then this is going to be our third signal. Alright, impulse response in time domain. Then our fourth will be the impulse response in frequency domain. Okay, then the same thing, our fifth will be the result for the time domain, and our sixth will be our result in frequency domain. Let me try to run and see what happened there. There you go. This is what we expected just now. Alright, as you can see, on our left hand side we have the filtering process in time domain, and in our right hand side we have the filtering in frequency domain. Right, as you can see, this is the not normalized signal. See what happened? We not normalized. Okay, so what we're supposed to do now, we're going to divide by maximum of MUL. There you go. All right, try to run and see there. Okay, we have 1 as our normalized signal. It's easier for us to analyze when we have a normalized signal there. All right, this is the filtering, the convolution technique in time domain. This is the result, and this is the filtering process in frequency domain by using multiplication. All right, as simple as that. Okay, thank you so much for watching. If you have any question, please post on the comment. I will try to answer. If you want for me to do any tutorial video, and please post on the comment as well. All right, thank you so much for watching. Bye bye.